Okay, and live again. Hello, Internet. So, working on the 3D printer still, and since the last video I put up, added quite a bit. So we created little capsules, and inside of these, YouTube, come on, SolidWorks. So inside of those, we've got the filament, and so it's on these spools being fed up through here. We'll have PTFE tubes go into there, and those go down in and go down to the carriage. So these just flip open and they latch shut. I do want to add something in the way of moisture removal in here, because a lot of exotic filaments just absorb moisture ridiculously fast to the point where you can't even leave them on the machine. You have to take them off at night and bake them in the morning. So yeah, that's something to worry about, but I haven't quite decided the methodology I want to use. I mean, there are lots of ways to remove moisture, and they have pluses and minuses. Um, so I also just quickly made like a cable of sorts for the extruder group. So got 24 wires there. It's a DB25 port. Basically, it's a printer port from an old printer, not from the days before USB, which is a long time ago, but these cables are still relatively common and affordable, so they work. And again, from days of yore in computers, this is just a DB9 connector, which used to be called a serial port on computers. It's used for mice and things like that. Uh, and I'm going to use that because it's got 9 pins, and I have these 3 units at the end. Each one has a limit switch and a temperature sensor. So there's 4 wires, but the limit switches all get 5 volts sent to one side, and the temperature sensors all get ground sent to one side. And since there are 3 grounds and 3 5 volts, that means I can eliminate 4 wires, and then I only need 8 wires to transfer 12 wires worth of stuff through a 9-pin connector. So that works out well. So I was just trying to decide exactly where I want this connector. Basically, I want it either on this panel or this panel. And I've already got a lot going through this one, so I'm not 100% sure that I want it on there, especially since I was thinking if I put it right here, this is pretty much a straight run. This is pretty much a straight run. This is pretty much a straight run. I don't have to go anything up above or below this, so that feels like my best option. So what I can do is, first of all, I was just using this sketch down here as a guide. I don't need that anymore since it's not even going to be on that panel. And I just made a couple of mates here. So all those mates are to this other connector, which are fine. I just want to get rid of this one so I can rotate it around and mate it over here. Okay, so just drag it over, and somewhere in there, I've got screws going right there, but that's okay. I don't want to run 90 degrees through here. I need to run down. So yeah, right about there I think will work. I want to create a sketch, and I can just convert that to get a reference, and I'm going to convert that to get a reference, and I want to make this a parallel, just so I can use it as a reference for its center and make it perpendicular. So that's coincident, and that turns black because it's fully defined. And do basically the same thing over here. And okay, so now the center of this line is the center, is where I want the center of the plug. So I'm just going to make like a circle there as a reference. This is all just reference geometry, so it doesn't have to be pretty. And then these are 25 millimeters apart. So if I make a line with a perpendicular and just make it equal for simplicity's sake. I want to do dimension from that point to there, and that is 25. And I can put two circles on, make them equal. Alright, how big is this hole? It's at 2.7 millimeter. That is small. What about on this side? Just back out of my new part here for a second so I can measure this. 3.1. 3.1 is doable. 2.7 is tiny. Why do they not match? Probably because they come with hardware. Alright, so I'll move this up and out of the way a little bit so I can actually see what I'm doing. Alright, so if it's 3.1, that means I can use an M3 screw. And I want to make this the midpoint of that. And also make this coincident with the line here. Then everything should go good, just for the sake of being complete. Okay, so everything is fully defined down here. And we can make everything for construction except these two holes. And just cut in, 10's fine. Okay, so I'm going to break those links. And then we can do two concentric made, or actually only need one because that parallel that was made before. Okay, so that is placed. I still need to have a cutout for it, but it's mostly placed. So if I do an edit and do a cavity using the actual part, that just kind of removes just the intersection or intersecting material. So I ended up with, yeah, that's kind of hard to make in a pretty much any machine. That's going to be a real challenge, especially with that back there. So I can just make a sketch. I'm going to convert all the inner loops and just delete the ones that I don't need. And then I can just do a extrude cut through all. Or, ooh, sorry, I do not want to go through all. I want to go just 10 deep. Okay, so that's set. Now I'm going to have screws coming in through the back here, and that would be a little challenging to do, so I just need to add a couple holes in the back as well. And make these a little bit bigger so it's not so hard to get in there with the screw. And just cut out the back. That was going to be through all. Alright, so now that drops in there. You put in the screws to the back, tighten them down. Yeah, this is starting to get a little bit slow because it's just so big. Alright, so I've got a bad mate with that hole that doesn't exist anymore, which makes sense. So just make a new hole, or make a new mate. There you go. Alright, so I still need a back shelf for that. I still need the wires for that. But I can worry about that stuff later. Things may change, then I'd have to change that whole harness around. So yeah, I've got the endpoints. I know where they're connecting. So that's good enough for the time being. I'm going to do a control Q because I've got yellows. Sometimes all you have to do is a regen, but not in this case. So let's edit this sketch. It's probably just a dimension causing it. And if we exit out of there, okay, now we are clear of errors again. That's one of the things that happens a lot in SolidWorks when you break a mate and lock it down. If you've already got a dimension there, instead of locking down the center point, which would make sense, it locks down the circle arc itself, which makes the dimension over-defining. Which, yeah, I wish they would change that, but oh well. Alright, so I've done some work here, probably 10-15 minutes worth. Gotta save often in SolidWorks. Alright, so got my to-do list. That's something to add. I'm not sure a good way to do it though. So let's look. So I've got the reservoir is pretty much stuck right there. It's just that it's on the front panel to look at the level. The radiator could be moved over to the other side. I don't see much value. The pump could be moved. Again, don't see a whole lot of value there, especially since it's nice and small and I don't have much that will fit back there. This one's just kind of wasted right now. I suppose I could put one of these 6 back there, but not sure what that would gain. Yeah, not so sure about that. What else do I need? I need lighting too. That'll be interesting. Inside of here, I'm designing everything for ideally about 150 C max operating temperature. So I actually don't know a whole lot about LEDs and high temperature. So yeah, that would be something to worry about. I'll do research on my own on that, not have you sit around waiting for me to read something on a Wikipedia page. So yeah, let's worry about the coolant drain. Want to be as low as possible, but still, yeah, I guess if we put it up here, basically I want it just to be accessible, which these feet, I mean they allow maybe a hose to run out from under it, but you'd have to lift up the whole corner of the machine if you want to use them. So ideally, I think I just want a horizontal one coming out the side, even if it means it doesn't drain everything. I think it'll drain enough. So I'm already got these 2 quick disconnects. I might as well stay in the same system for the drain. And do I want it on the front? I don't think so. I think I'd rather have that on the back, maybe near the radiator. Even though, I need it near, yeah, I need it near this reservoir. Could I put it right on the side? put it right there. Would that work? Or should I just go ahead and have it sticking out the front? It's more of a maintenance thing, so yeah, I'll put it right here. And see, this is set for 1/8 of an inch, and that looks like an 1/8 inch panel. For anyone viewing this overseas, I'm sorry, but 1/8 inch is what is available at the local metal suppliers, and even though I work all in metric and I call it 3.175 millimeter in CAD, well, it's just that's what's available here. And not much I can do about that. So I want it to be relatively close over here. I want it to be relatively low as well. Just gonna have it kind of floating there. I'm gonna edit this panel, and I'm gonna make a circle that matches this. A lot of my library parts, I put this pink surface that just represents the outside of the threads, which makes it easier to do things like this. Just offset by 10 works, and I want to offset that by 10 as well. Okay, do a tangent and a tangent. And for construction, not for construction, and then I can just use that to cut through. And I'm going to break those references up at the top. Okay. Go parallel there just so that it's fully defined. All right. So it won't get every last dropout, but it'll get most of it out anyway. So I need fittings now for that. And just use the same one that I'm using for everything else, basically. So this is an 11. What version is this? Okay. Might as well make it the 13. So I believe this is the 13. Or is this also? Just double check that they're both the same size. Okay, yeah. Got the sizes right. Then this plug needs to go away. So I'll just suppress that. And put this in its place. That's not what I want. I want to drag apart. There we go. Alright. So we got the fitting, and we got the fitting. For a relatively easy run like this, I don't mind. Just go ahead and make the tube right away. So I've got these pre-made end of hose pieces. I like using these because sometimes you kind of overestimate or underestimate the size of a hose based on its theoretical dimensions when it's flexible like this. So I'll model it up to in its flexed condition. Yep. And just make them coincident. And make this coincident as well. Alright, so then I just need to connect those two together. And I'm guessing I cannot make them coincident. Oh, yep, it wants to rotate because I did not mate to there. Okay, good deal. Let's do the same over here. So that stops rotating. Doesn't really matter what direction it is because it's round, but it can still rotate, so let's avoid that. And quick regen appears to have gotten rid of the problem. Alright, so they look almost in line, but I'm sure they're not exactly in line. That just doesn't usually happen. So, and anyway, I want to model it with a little bit extra flex or a little bit extra bend, just so that I know I've got enough material when I actually make this hose. Actually, come to think of it, this hose I need to be basically as tight as possible, so never mind on that. So what I can do is I can actually use a 3D sketch to figure out the angle that this should be at. And how I can do that is I will make two lines to start, and I want this one to be normal to that surface, and I want it to be concentric to something in there. So let's hide this for the second. Okay, so I want it to be concentric with that. And I want this one to be concentric with that. And just put this on the plane. Put this on the plane. Okay, so I can use that as a reference now. And I can just make a new line. It's also perpendicular. These are perpendicular because that perpendicular, or the fitting was perpendicular. So equal. So now, in theory, I should just be able to rotate this around wherever it's convenient. Okay. And make another one over here. Put that on plane. And use that plane. So now I've got the ends. And all I need then is an arc, or possibly two. Yeah, I'm going to need two arcs. That tangent, make this tangent. Then I want to put a line here, which I'm going to make tangent to both arcs. If I can click it. Now if I make the arcs tangent to each other, they go coplanar, which messes everything up. And which apparently this is getting messed up anyway. Some kind of weird angles. Seems like it should go tangent. There we go. Just at a unfortunate angle. And if we go equal, alright, so we can pretty much define how much bend it is at that point, and I want it to be pretty tight. So that works. I'm going to turn everything to construction and just grab the lines that I want, or the arcs I want, as soon as it lets me. There we go. And got the 2 arcs. They're no longer for construction. Alright, so I can make a new part. And it is way down there. There it is. And I want to do a 3D sketch where I just copy these 2. That's all I need from that 3D sketch. And I need a 2D sketch. I just copy these 2. That's all I want from that. Then I can select those 2 and do a sweep. Alright, and okay, that looks a little bit broken, but that's fine. That's how we can put that where it belongs in a minute. So I'm going to break all relations because I'm about to do some changes. And also because I can delete that sketch right away. So many mates. Alright, so I've got 2 ends of hoses, and I've got the hose itself. Turn this into a new subassembly. Okay, open that. Alright, so this should be fixed. These are not. Alright. I can just mate those as coincidence. Not often I use this mate, but it'll be fine here because of what I'm doing. And these are just round, so they'll say undefined unless I do something to a plane, but that's fine because I want to remove all appearances. And then I want to do a save as a part. And all components, save. I can close this. And as soon as it lets me, go back to my 3D printer and open that hose up. Now I've got one part, but it's divided into 3 bodies, so I just combine those 3 bodies. And the material is going to be silicone rubber. Try removing all the appearances. Try silicone rubber again. Okay, sometimes bodies just get kind of broken like that, so I'm just going to make a copy of it and delete the old one, do a Control Q, and now it's a silicone rubber hose, except I color my hoses blue if they have coolant running through them. Okay, so I can insert yet another hose, and I can get rid of this assembly, don't need that anymore. And let's see, we'll start by mating to this, and mate to there. Okay, and then we have to show that fitting again. Might as well just show everything. And then we can do a mate to there. Alright, good deal. And everything is fully defined on that hose anyway. And the fitting is defined now. Both fittings are defined. Alright. So it looks like we might have actually, yeah, because the bottom of the reservoir is the lowest point in the system, and this hose goes down a little bit more from that. So, yeah, other than maybe a little bit of residual in this tube, or occasional in a bend of a tube, that should drain it really well. So yeah, I want to save this now. All right. What is next? Labels for circuit breakers. I haven't even decided which circuit breakers get what yet. Scale for level indicator. I don't really see a point in that. It should just be maxed out, but we'll worry about that maybe. 1 kilogram spool setups. I could do that. Let's see. Where is this located? It's in an old 3D printer folder. That should be in a hardware. Okay. And this is old. So this should be, the whole thing should be just, we'll call it ABS just for, that's probably what the actual that is. And we want this to be pink, because that's just simulating if it's at maximum filament, and then we can hide it when it's out of filament. Alright, so I'm going to save this and go back to 3D printer and drop it in. Alright, so if I hide this, then we've got these, and open that. I'm going to do a save as, call it the 1 kilogram spool setup. But I want to do a save as copy and open, so that 5 kilogram one that's already there doesn't get affected unless I make changes to actually modify the parts. Alright, so I want to put that in there. So yeah, 5 kilogram spools are a little bit larger than 1 kilogram, just a hair. I can just suppress this for now, and I want to do a probably just do a concentric on it. It's not how it'll actually sit, but different spools will behave differently. And I figure concentric's probably best because it's got plenty of room to drop down, but yeah, it doesn't really matter what way it goes in this thing anyway because it's huge. Okay, so that's there, and then this is currently coincident with that. So we can move it down as far as we can go. Okay, so there is so it'll sit in this one. There's a little bit of slop, but that's okay. Not too much. Alright, so that's fully defined. Save. And I don't need that open. Don't Don't need this or this open either, so might as well close them. Alright, and I don't need that actually. I can insert these. So I can have 6 of these. Just in case I want to show it with just 1 kilogram spools. And maybe I'll notice something when I put these in that causes a problem and I'll have to adjust for it. Alright, let's minimize some of this stuff so it's out of the way. So I'm just going to hide all those. And again, I've just got so much stuff open. So I've got the latches and the covers. I'm going to add those to a folder. Call it filament protection. That works. So that way I can just hide all that at once. And now it's a little bit easier for me to work in there. So let's see. Just start meeting and see what happens. Don't quote me on that. I'm not sure I need to do all the sides to tell what's wrong, if there's anything wrong, but might as well just have them there, and then they can just be in there unless something has to change, of course, but we'll hope that nothing has to change on this anyway. And drop that in there. Just one more concentric, and alright. Now, other than these, which seem to be set up well, I don't know where everything went. I assume it's inside somewhere. Hide. Okay, yep, they dropped inside. That's fine. Just drag them back out. SolidWorks gets kind of slow sometimes with a lot of stuff, and you think it accepted the last command and you're on to the next, and meanwhile it hasn't registered anything at all. Alright. Yeah, it's going really chuggy now. Alright, those look good, those were good. So I just need the ones for the front. That must have been what I hid when I tried to hide the front. So let's just show everything again. And hide that whole section again. Okay, and we can hide the spools as well. Alright, then we can actually mate these down. Right. And just so these are fully defined, let's see. That's one, that's the next. So I want the Y with the Y. Can I flip them the other way? No. Alright, it's fine. So again, we want to do the Y with the Y. And two more. So Y, Y, mate. Alright, so those should all be fully defined now. Alright. Just match the formatting of the other folder. Alright. So already I'm seeing a potential issue. So yeah, I'm kind of glad I did that. First of all, I'm going to save. But potential issue I'm seeing here is that the angle that it's going to be drawing off is going to be on the extreme side. So if I can move these in towards each other, that would be a plus. Problem with that is I can't just move them straight in because they're mounted to these bars which are at an angle. But I can work around that because these protectors are pretty deep. So if that's the edge, we've got all that way down we can go. So I should be able to just move them in and also down at the same time. And yeah, I should be okay doing that. So let's see. These are 195.2625. Just put that in there. Alright, so that's what ones that I actually physically had my hands measured to. Well, with rounding. And then, but let's just say maybe someone's making one absurdly big. Just they're ridiculous. That's 50 millimeters bigger than it needs to be for this one, and this one is frankly a lot larger diameter than it needs to be. It's not as thick as some other filament brands. So yeah, we can do that. So we want to just open this group, I guess. So this is just that whole front section, including the insulation and everything. And I'm going to do a sketch out here, just in the assembly. And there. I want to convert both of these faces, just so that I've got the lines at the end that I can draw down. I need my circles out of the way to do that. And then, okay, so this is a horizontal, so we can go parallel with that, go coincident, want these to be equal, and want them to be 250, plus, say we want 10 millimeters clearance between the two spools. So that would be 5 extra millimeters each way, but that means I have to add 10 to the diameter as well. Okay. And then we can make these tangent, and we're fully defined. Make all that for construction, Actually, just save these. And then I'm going to edit this part. Oh, edit part. Put a sketch there. I want it to be 8 millimeters, I believe. Yes, 8 millimeters. I can just make it equal, actually. And make it concentric. Good deal. And same here. Equal. Okay. And then I just want to do an extrude cut down to, ooh, problem. So this is not a threaded hole. It's connected with a nut, which I figure is kind of a pain, but it's just close enough to the end that it's possible to do. Yeah. Suppose I could just go through and put the nut on the other side. I don't think there's anything back there that's going to cause issues with that. Would not be a quick, even still, not a quick thing to switch out. And I suppose these could be threaded directly, and these, even the bigger ones are only 5 kilograms. So yeah, I can do that. So if I open this up, I don't want the new hole, I want the old hole. Change that to 8 minus 1.25. So that's the tap drill size now. That works. And yeah, it actually did the same. I think it might have mirrored it around. Let's see. 6.75, 6.75. Yeah, that's the same part. So 43 and 43. Okay, that works. So yeah, now this is basically just a tapped hole. And the bars just thread straight into those. That works. What if I hide this? Does everything look right? Okay. Break those so I can get rid of that sketch. Okay. So now 5 kilograms goes there. 1 kilogram goes there. And I can get rid of a nut, actually 2 nuts right now, because I don't need them anymore. They must be in the proper assembly. Yeah, just start hiding things so I can get at what I want to see. Alright, so I need to get rid of those nuts on all of them. And I think that's just at assembly level. No, it's... Oh, it's part of the spools themselves. Well, that actually makes it a little bit easier. Okay. So just get rid of the nut. Oh, might as well fully define this as well. Okay. Do the same thing at the 5 kilogram ones. Don't need the nut anymore. Okay. Alright. I need to redo all those concentric mates for the 1 kilogram spools. if it'll let me do multiples. I think so, yeah. All right. So these I can go ahead and make new mates now, I believe. Oh, 5 kilogram. Leave those alone. These. I can just go to here actually. Oh, I cannot do that yet because I don't have the proper holes. Open that in position. And yeah, we need basically these holes again down farther. So I go in here, I'm gonna hide the main body so it's just out of the way. I'm gonna convert these, and I can show the body again. Make those for construction, and just make 2 more circles that are equal to the existing holes for the other ones. Equal, and just do a cut through all. Break my externals. And yes. Okay. Now I can actually mate to that, because I can actually get to that. Okay. What do you do in SolidWorks? There we are. Hide these. Alright, so those are made. I guess need to make these too. Just get these entire spool assemblies out of the way so I can actually see what I'm working on. Alright, so there, I've just got the 2. I think this one has the same through, but I'm not sure. Okay, so that's the same. The outer panel is not the same though. So if I just open up this whole side panel group, alright, so I need 2 more holes. Did I just tell it to insert a part? I sure did. I did again. Edit that part. Create a sketch. I want to hide this body. Convert these holes. Make them for construction. Make 2 new holes. And then just make these all equal. Fully defined, make a cut. And break links. Alright, so that is that side panel ready for 1 kilogram spools. Okay, that worked just how I would have wanted it. Not. Okay. Let me pull this out. Nope. So let's try just doing a regen, see if it pops out on its own. There we go. It's fully defined, fully defined. So now I just need the front panel set up. And best way to do that, I'm going to get these two. Actually, I can just use those themselves. I want to measure from there to there. And of course, it's a long, weird number. Alright. It's fine. I'll just copy this. Alright. And I can hide this. And go. Just use one as a template for the other. So then I can edit this part and do a sketch on this part. Just copy that and do an extruded cut up to next. Okay. Definitely need to break those links because I don't want to keep the source part there anymore. But before I get rid of that source part, I can grab this. Oh, these are both 43, right? They sure are. Okay. So copy that basically. Oh, those are the same too, so I am set. Alright, let's open this whole front panel group by itself. And again, kind of edit, create a sketch on plane, hide the body, convert the circles, make them for construction, and then make these, bring the body back, and I want to do equal mate between the two new circles and the old one. Fully defined, do an extrude cut, and then I want to break all these links, not that many actually. Fully defined, so we save. Alright, let's show everything again. Actually, if I just find those filament spools, I can just show these. And make a new mate to there. And there. And of course it disappeared somewhere, so just do a regen. So that's fully defined, that's fully defined. Alright, so yeah, now it supports both 1 kilogram and 5 kilogram spools, which is great. It gives people a little bit more selection. If you want to print with your gold infused filament that costs $1,000 a kilo, well, yeah, maybe you don't want a 5 kilogram spool of that. So, alright. Make sure I don't have any external refs. I'm going to do a show all and then a regen. Just want to make sure I've got nothing funky in here. Okay, so it's still underdefined, but everything looks good up there. I'm gonna save. I'm gonna save everything inside. I'm obviously not done yet. I've gone through a few things, so I've cleared that line out. I don't need that anymore. No, I'm not gonna do that. Movable fan filters. Yeah, that's something that needs doing. Did I make that? I think some of these I may have just forgot to check off. But nope, not that one. I did not do that yet. But before I can do that, I need to figure something else out. So need lighting. Again, I'll do that once I do a little bit of research on what kind of LEDs can handle this. Air heater control system. I have everything for that except the actual logic for it. So go down. Needs lower area ambient air temperature sensors. Could do that. Could definitely do that. Let's see. Just move this one down to the end as well. And that as well. And let's get this all the way. This is just an old note that doesn't even, yeah, I'm not even using that anymore. I changed that design. So I've got that. Don't have all of those. Don't want that. That can go down to the bottom. That's electronic stuff. I'm gonna try to save that for last. Okay. Excuse me. Alright. I think that is our next priority. But yeah, I'm gonna take a break here for 15, 20, something like that. I'll be back. And it looks like no one's watching anyway, so yep, just gonna take a break and I'll be back in a while.